The Energy Warden Policy module is a web-based system for monitoring the real-time in-situ performance of different renewable energy devices installed in a building. These are photovoltaic, wind turbine, solar thermal, and geothermal devices. The Energy Warden Policy module monitors also the performance of the building as a whole in terms of CO2 emissions. The Energy Warden Policy tool functionality is based on existing international performance standards. These standards have been appropriately adapted for in-situ monitoring since these are usually meant for laboratory use. The user should first register his product by inserting the name, contact details, company name, the product serial number if it's available, and the password. Then the user should log in into the account. In order to monitor performance and various other operating parameters of a new system, either photovoltaic, wind turbine, solar thermal, or geothermal, initially the user should press the plant configuration button in order to import the plant data. Select the power plant type from the drop-down menu. There are 4 options: photovoltaic, wind turbine, solar thermal, and geothermal. Then press the New Plant button and insert the requested data. When you are finished with the plant configuration data, by pressing the button Sensor Data Import, the installed system should be selected from the drop-down menu, and the sensor data will be uploaded and imported to the database automatically. It should be pointed out that the Energy Warden Policy module can plot a wide range of different charts, for example, area charts, bar charts, column charts, line charts, and 3D charts. Moreover, the Energy Warden Policy module can plot results for 3 different pre-selected periods: the 7, the 30, and the 365 days. Also, there is the option of showing all the available data by selecting the option All Available Data. Finally, a specified period of time can be manually selected using the option Data Range. The Photovoltaic Policy module allows the monitoring of the PV system operation and the calculation of performance parameters like plant energy, revenue production, the efficiency of the system, CO2 savings, etc. With the system plant type set to photovoltaic, proceed to enter the following data: the location of the system power in kilowatts peak, the annual estimated production in kilowatts hour per kilowatt peak, the CO2 conversion factors, the energy selling price, the tracker type. It has 3 options: no tracking, single axis tracking, or dual axis tracking, the site average daily solar radiation, and the site average monthly temperatures. The section array configuration data are then specified: the number of sections, the azimuth angle, the inclination, and the power are entered, followed by the number of arrays and modules, and finally the module and inverter types and the sensors installed. For example, in the case of the BRE Innovation Center, there is 1 section with 1 array and 18 modules. There are 4 types of sensors: DC PV output power, AC inverter output power, DC output power to storage, and DC output power from storage. The sensor data should then be imported. With the correct power plant type and examined plant specified, select the type of sensor from the Select Sensor drop-down menu, so that all measured values from sensors that are needed for the performance calculations are uploaded to the Energy Warden Policy module. The types of sensors available in the case of the BRE Innovation Center are the PV output, inverter power output, solar radiation, air temperature, power to storage, and power from storage. The graphs of the plant operation and performance can be plotted by selecting the Performance Monitoring tab and specifying the measured or calculated values to be plotted, the plot period in the plot period drop-down menu, and the type of chart preferences. The measured values include solar radiation, which is the solar energy falling on the surface of the PV panels, the ambient temperature, which is the temperature of the surrounding air, the surface temperature, which is the temperature of the PV panel surface, the DC PV output energy, which is the DC output energy produced by the PV panels, and AC inverter output energy, which is the AC output energy produced by the inverter. The calculated values include plant performance ratio. This is the ratio of the actual and theoretically possible energy output. The plant final yield. This is the ratio of the grid injected energy and the nameplate power of the PV generator under standard test conditions. The load efficiency. This is the efficiency with which the energy from all sources is transmitted to the load. The BOS efficiency. This is the efficiency of the balance of systems components. The BOS losses. This is the losses of the balance of systems components. The plant CO2 avoided. This is the carbon emission savings. Instant conversion efficiency. This is the ratio of the electrical power produced by the photovoltaic device to the power of the sunlight incident on the device. The plant production, the energy produced by the plant, and the plant revenue, which is the revenue produced by the PV plant. By pressing the reporting button, a full report of the results can be printed. Thank you for your attention.